The purpose of this demonstration is to show you some capabilities of Erdas Imagine object-oriented feature extraction tools. Originally we were talking about segmentation in Imagine, but we are now talking about a bit more generic approach. How to extract information in Erdas Imagine when the high-resolution imagery is the source of the information. The file I'm using is some Navestovo aerial image, 0.5 megapixel size, containing RGB and near-infrared channels. The tool I'm using is Imagine Objective. It is our object-oriented feature extraction tool. I'll create a project for that. First, Namestovo buildings number 7. Feature model is Namestovo buildings number 7 too. The first thing you need to define is a variable, which is basically our input data. And that variable in this case is our Navestovo building. So I'll pick up the building, the image. I pick up the image, and that is our input data. And that is our only input data, what we are going to use in this process. I'll start working in this corner of the image, and I define, by clicking this button, I define that I work just at the moment when developing this process. I just work with this display. I'm not running the whole image at the beginning because it takes a while. The first step, or the whole process in Imagine Objective, is defined by a step-by-step basis. First you define something with your two raster pixels, then you turn those pixel classifications into a segments, then you do something with those segments, then you do convert those segments, raster segments, to vector polygons, then you do something with the vectors, do some processing for those, and finally you clean up those vectors. So first thing is to do some raster pixel processing. This is done. There are some few features or few ways of doing it. The one we are always or mainly using is single feature probability, which is basically a simple trained classification. First we do some training samples. So I digitize some buildings. This is the building we want. And we say that is both pixel and object. This is the dark building we want. We add that. This is the slightly red building we want. We add that. And this is the bright building we want. And we add that. Then we digitize something that we don't want. We don't want anything like this field, and we say that is a background. It's a pixel value now. So we add something that we don't want. We don't either want this field, and we add that also as a background, and we don't either want anything from the road, like that, and we add that as a background. Then we have to accept the training samples given here. So in practice what it makes is calculate some statistical information of the training samples we have given. The next step is then do some segmentation. So we segment those classification results. Then we do something for those segments. So in this time we do some size. So first we'll do some probability filtering. So we are only accepting segments where the classification probability is over 0.75. And then we'll add some size filtering. We say that minimum size of our building is 200 and maximum size is 1000 pixels. And then we convert those to polygons, and we put a stop here. So now I'm running something with the pixel-based classification, segmentation, doing some analysis for those segments, and then finally turning those to polygons. So now I'm running these 4 first steps to see the results, what we are getting up. The idea of objective is that you define the process in this small window, and when you have defined the process and set up the parameters in the right way, you can extract all that information to a bigger for the whole datasets. Now we can compare. Here is the result. So that is our working. First result visible here is the raster pixel, the pixel-based classification. The bright pixels means that there the classification result is fairly high, so we get pick buildings quite nicely. And then there comes the segmentation result. It's not very good one, or it's not very intuitive one. Here comes probability filter. So we have filtered away everything that has a probability less than 75. Size filtering drops out the small and huge regions, so this is the buildings where we are getting, and here is the polygon version of those buildings what we are getting. So I think it's quite nice, not exact but quite nice. So we are happy with the results so far. Now the next thing is that we start to do something with those vectors. So we start here, and first we do something like, and we stop here. Actually we can say alright, now we can start doing. First thing is that we do some generalize for those vectors. That's fine setting. We may do some smoothing like here. So we do some generalizing and smoothing. Then we do we are looking for square kind of buildings. So I search for the rectangularity. That's the function we want to use here. And here we have to use the training data what we have. We are using the training data what we have already digitized, so I just say accept. And then as a final step we do some cleaning up of the results. So we'll do something like, for example, dissolve to combine all those separate pieces of vector. So some generalizing, smoothing, then some rectangularity, and finally we dissolve so that we combine all the separate vectors together. And we'll see what comes out now. And here we have our result. So we do the swiping again, and we leave the dissolve as a working one. That is at the moment our final result. There are some other functions like putting a square around the building, but this is now a quick example how you can extract information. I think quite nice results. Some buildings are not as they should be, but some buildings are really good. So this is the process how you define. You can extract any information, whatever what you want. It just depends on how you define these settings. I won't run this now for the whole process or whole file because it takes a while because the files are fairly large. I'll just take an example. I'll quickly show you the result of what we got out when I run it for the whole image. It takes something like 5 minutes, 10 minutes. Here is a result of that process for those same settings for the whole image, and that is actually quite nice. Some problems with the big buildings because we have the size filters, but for example the small buildings here are really nicely extracted. All of them are extracted really nicely just with those settings we made in last 5 minutes. So objective is a Erdas feature extraction tool for high resolution imagery. It's a very capable. It's just up to you how well you define the process, how well you define the parameters, and that defines the result you get out. It gives you a huge amount of possibilities, huge amount of flexibility to extract whatever you want from the images you have.